Good morning, grade 11s. How are you? It's Monday. I hope you had a good long weekend. It wasn't a long weekend. It was just a regular weekend. But who cares? Today I'm going to do just a few questions. We're going to learn that trick that I talked about, which makes getting to Vertex Form easy if completing the square is a pain. It's only going to be like a 10-minute video, and then I'll give you a couple of pages of work that you need to do on that you should get done by Wednesday before we go forward. It's not for marks, so it's just work in your books. Okay, I'll talk about them when we get to it. So let's get started. So here we are on the bottom of page 106, where I put it all together. So what I'm going to make sure we talk about today is I'm going to show you this trick right here that I was talking about yesterday, or Friday. All right. And that trick is outlined right here. When you have a quadratic function like this, we already know automatically that that is our y-intercept. Right there, we know our y-intercept always. So the only thing that's missing is our x, is our vertex. When b is even, we can always divide it by 2 and square. But sometimes that is great when b is even and a equals 1. But sometimes a is not even, or b is not even, and a does not equal 1. In that case, this trick is very handy. That right there, if you take the negative b and the 2a, that is going to give you your vertex x coordinate, which is also, of course, the axis of symmetry. And that is really handy. And I'm going to show you how to deal with it when we get a chance to. Now, remember back when we started talking about vertex form, I told you I couldn't remember which way my notes went. Sometimes people write P and Q there. Sometimes they write H and K. It doesn't really matter. We just remember this is vertex X and this is vertex Y. So let's do this thing. So let's look at A right here, which I'll do in black. So this is what your thought process should be. All right, I got to get this into vertex form, so it's not. So I look at B right here. That's my B, right? Is B even? Yes, it is. So then I look over at A. Is A 1? Yes, it is. So that makes this a really good candidate to complete the square. So let's go ahead and do that. Remember, f of x is the same as y, so y equals x squared plus 10x minus 6. Now, even though we are eventually going to need this k back over here, I like, as you all know, I like to move this over here so it's out of my way. Sorry, the dog needs out. So y plus 6 equals x squared plus 10x. And then, of course, we divide by 2 and square to get 25. That means we've added 25 to the right, so we add 25 to the left. And now I have y plus 31 equals x plus 5 squared. And then I move the 31 back. And then we want to sketch a graph of the function labeling the vertex and the y-intercept. So, make sure I've got enough room here. Sketch a graph of the function 5, negative 31. So since that's positive 5, we go over here, negative 5, and go down 31. Negative 5, negative 31. And there's our vertex. Since A is positive, we know it's going up, and we know our y-intercept is negative 6. So we put a dot there, negative 6. And of course, this dot over here. Now, we're smart kids. We went over, from negative 5, we went over 5, which means we go up 5 squared, which is 25. Negative 31 to negative 6 is 25. So this is 0, negative 6, which makes this negative 10, negative 6. And I didn't ask you to do that. I just want you to be aware that it's still following the quadratic pattern. So let's have a look at B. And again, we check. First place we check. B. Is B even? No. In this case, B is odd. So this makes this a good candidate for vertex x equals negative b over 2a. So I come down here, vertex x equals negative b, which is 5. So negative 5 over 2 times a, which is 2. Now, that is, of course, positive 5 over 2. That is my vertex x value. Now, y equals x squared minus 5x plus 2. There is an x value. Now, I know that it's a fraction, and I know we've got to deal with it. And I know that you don't like that. If we were to complete the square with this, then we'd have to be adding fractions all over the place. This is just another way to do it. If you're comfortable completing the square and using a fraction, go ahead and do that. So this becomes 5 over 2 squared. Vertex y equals 5 over 2 squared, because this is an x value. That's an x. Minus 5 times 5 over 2 plus 2, which gets me 25 over 4 minus 25 over 2 plus 2, which is 25 over 4 minus 50 over 4 plus 2, if it's going to be over 4, is 8 over 4, which is negative 25 plus 8, negative 17 over 4. So now I know my vertex x right there, my vertex y right there, and I can go ahead and graph it. Positive 5 over 2, negative 17 over 4 is down there. And I know my y-intercept is positive 2. So it looks like that. Now let's look at C. In C, I see that is even, but I have a 3 there. So this is kind of your choice. Well, they're all your choice. But for C, I'm going to complete the square because that's even, and this factors. And for D, I'll do the other trick. So C, y equals 3 squared minus 6x plus 7. Bring the 7 over so it's out of the way. Y minus 7 equals 3 x squared minus 2x, and then half it, square it. Negative 1 squared is positive 1, which means I've added 3 times 1. I've added 3 to this side, so I got to add 3 to this side. And now I've got y minus 4. That's not supposed to be blue. Y minus 4 equals 3 x minus 1 squared. Y equals 3 x minus 1 squared plus 4. So now I know my vertex is at positive 1, positive 4. And I know I'm going up because A is positive. My y-intercept is 7. And I just think to myself, okay, I went over 1 and up. If I go over 1, and I have an A, I go over 1 on the x-axis, and I go up ax squared. Well, a is 3, 1 squared is 1, 3 times 1 is 3, so I'm doing this one right, because I went over 1 and I went up 3. So then if I go over 1 here, I'm up 3, and that is 2, 7. And there's my parabola. And lastly, let's do it in a jaunty color. Let's do this one in purple. Now, I said I'd do the other trick with this one. Even though that's even and this factors, I just want to use this one more time so you see it in action. You never have to use it, but a lot of kids don't like completing the square, and they like this. So I'm showing you both. You choose. And remember, our vertex x equals negative b over 2a, which you recognize as part of the quadratic equation, of course. The quadratic formula, I mean. So that is negative 8 over 2 times negative 2, which is negative 8 over negative 4, which is positive 2. So there's my vertex x is positive 2. Since it's an x value, we can go ahead and plug it back in. 2 squared plus 8 times 2 minus 3, which gets me 2 squared is 4 times negative 8 is negative 32, plus 16 is negative 16, minus 3 is negative 19. So there's my vertex y, and then I just graph it. My x-intercept is at 2, negative 19. And since it's a negative parabola, it's going I screwed up. Oh, I'm such an idiot. 2 squared is 4. Negative 2 times 4 is negative 8. Sorry, guys. Negative 8 plus 16 is positive 8. Minus 3 is positive 5. There we go. So I've got a vertex at 2, 5. And since it goes downward, it's a negative a. It's going to go down, and I know I've got a y-intercept at negative 3. And that makes good sense because I went over 2, so I should have gone down 4, but it's doubled because it's a stretch factor of 2, so I went over 2 and I went down 8. 5 to negative 3 is 8, so I know that this point right here is 4, negative 3. Sorry about that mistake in there. So that's what you got right now. So you've got two choices when you're graphing these. As long as you have general form, you can either complete the square or you can use negative b over 2a to get your vx and then sub back in for vy. Your choice. I want you to do page 108 and 109 by Wednesday, please. All right. Doesn't take long. Make sure you do a few. If you don't feel like doing all, don't. Okay? We'll see you guys Wednesday, and we'll hope to see you again at the live meets.